Today is March 24th, 2024, and exactly a year ago from today, at least of when I'm recording this video, a massive wedge tornado obliterated Rolling Fork, Mississippi. Now, this is a very important video to me. I'm making a case study on it, so welcome to my case study. This tornado is very important to me because it's kind of the main tornado that kicked off my own weather enthusiasm. I made a case study on the Coal City EF3 in 2015. I believe that's June 22nd, 2015. That was one of the events that made me start like enjoying or thinking about weather and meteorology. But Rolling Fork EF4 is really a huge Kickstarter. I started getting interested in meteorology about I think 2 days before this event, and when I saw this tornado, I was like, "What happened?" I really wanted to know. So you can see here this a picture of this tornado from Ohio Storm Chasers. I can link their video in the description here, but the horizontal vortices, strong wedge tornado, huge tornado. It did a lot of damage. I think about 16 people died as well, unfortunately. Very interesting meteorological event all around, and I'm going to be talking about that today. Now, first of all, one thing I wanted to say, this event was extremely well forecasted. This here is the day 6 outlook. So this is from, ooh, very far ahead of the event, March 19th, 2023. So they knew there was going to be severe weather day before and in this Mississippi region 6 days ahead of time. 5 days ahead of time, they made this risk a little bit smaller, but you can see it continues. Day 4, again, right in that little bullseye right here. Day 3, they had an enhanced risk with the hatched area for probabilistic severe weather. Day 2 saw a moderate risk, very much like the day 1 we'll see in a second. But again, hatch tornado risk, the main possibility being tornadoes. It's the main risk of this event. Possible hail, really, but mostly tornadoes, discrete supercells, and maybe some wind damage as well. But hatched, all hazards threat for the south, but mostly tornadoes, interestingly enough. The day 1 outlook saw basically the same thing. And this is the 20Z outlook, basically right when storms were firing, or beginning to fire anyway. We saw showery activity in like the Louisiana region. We'll talk about that in a second as I go into the what really happened, but moderate risk here. Hatched tornadoes, much the same. They add a hatched hail risk and hatched wind risk as well. So meteorologically, I have my meta-analysis archive here, and this is basically the nighttime of March 23rd into March 24th morning. So at 12Z here, this is our 12Z. Let me get my pen out real quick. So at 12Z, which is about 7 a.m. Central Time, the morning of the event, nothing really going on here, right? Kind of see a little surface low down here, but there's not a huge, strong surface low, especially not for a low region we're looking at. Clear this real quick. As we move this forward, see surface low begins to form here around Oklahoma, Texas, and Arkansas, kind of right in this region. And you can see here, these wind bars are a little hard to see from this far away, but this is about 15 knots of flow going up, so pretty strong southerly flow pulling in warm, moist air from the Gulf of Mexico. Get closer to about 0Z, 20Z again. You can see the surface low right here. It continues to wrap up, strengthen. And at 20Z, we have a 1000 millibar surface low. So pretty strong, very strong contour bars here, contour lines here as well, and good wind barbs. I think 20 plus knots of flow at this point, moving up. So very strong surface cyclogenesis. This would be our main forcing for this event, and I believe the Ultron at this point was like draped way back here. So we had a pretty big open warm sector to deal with. Storms can kind of fire wherever they wanted to in this region. Look at the different levels of the atmosphere as well. The 500 millibar level here. You can see a huge trough. This is a 0Z here. Good defluence. See these contour lines are kind of spreading apart as you get higher up in the atmosphere. It was an amazing drawing right there. But kind of get our area of interest being in this region. Compared to this bar and this bar, there's definitely good defluence aloft, and I believe this product shows a little bit of it as well. This may have even strengthened closer more onto the night. But yeah, there's our big, huge trough, very high amplitude, basically stretching from this whole region, very large wavelength as well. So low moving trough that would end up bringing us just allows for severe weather and a good trough in general for severe weather, especially. Look at the 700 millibar map for look for short waves. Also right here. Here's at 19Z. We'll move forward a little bit. And you can see here, yeah. So It's very well defined. I can't really zoom in too much. I can try to a little bit here. You can see the Mississippi, Arkansas region. Something I talk about on this channel a lot is the presence of shortwaves. You can see this contour line here. How it kind of kinks down, right? It's a little bit of a weird representation of it. I'll try to use a different color for it. You see, usually contour lines go about like this, right? But in this case, you can kind of see again, here's our little kink in the flow. It moves a little bit with the entire event. This is basically over the entire region of interest, right? This shortwave was likely bringing some of our it was forcing some of the air from the surface to rise and condense into clouds and storms. Because that little showery activity in a situation like this can be what really starts our storms to fire. I'll look at the 850 millibar map as well so we can understand the lower level jet. Low level jet is what kind of spins our supercells. And it's not nice for the colors, nice for the eye, but I can kind of understand here. I'll zoom in again so you guys can see a little closer. Lower level jet, we're seeing 40s, nearing 50 knots of good lower level jet. So that's pretty strong lower level jet there, especially over the whole region, which is probably strengthening those supercells, especially into the nighttime. Zoom out again. Yeah, as you can see the 50 knot wind barbs here, right about at storm hour 001 1Z the next day. That's about when our tornado happened. Also see our damage path right here to see a timing of the tornado. So this is from Tornado Archive, very useful little website. It's about 1Z is when our tornado was beginning to ramp up. So right about here, strengthened the lower level jet as well. That really helped our supercell. And I'll get into radar imagery in a little bit. Dew points, at this point, you can understand definitely good dew points being expected into the region. At 0Z, I believe these are maybe 70s dew points. Yeah, strong 60s dew points in this whole region, the whole timing. See, 0Z, I actually don't have a 1Z product of this, unfortunately, it doesn't look like, but here's our 0Z, and you can see that strong surface low as well as all these very strong moisture. You can also see the small semblance of a convergence band right here, and I'll try to zoom in for that. Not too easy to zoom in, but I'll do my best here. So, and they don't have, it's very hard to find archive data for these events, at least easy to view archive data. You can see here, here's our wind barb, and it's kind of moving a little bit more towards the east, right? So you can see our wind barb is like this, like that. It's right here. So this is one we're looking at. You can see a little bit more out of the west, and this one's a little more out of the east. And that would kind of semblance a little bit of a convergence band, maybe. And it's about what we saw in the radar imagery as well. It a little bit of showery activity in this whole region right here, which actually, that's immediately how we got our Rolling Fork tornado. We had a little bit of showery activity right in this little region, probably along this convergence band. That would move this direction. We're going to go to the cape values now just to see the amounts of cape again. Probably guess it's going to be, it's going to be significant because we did get a tornado this day, but ML cape, mixed layer cape, about, again, it was kind of moving its way into the region. Not super duper strong. In a way, that's a good thing because if you have super strong cape, for tornadoes at least, you might get a more of a messy storm mode, and that doesn't really favor tornadoes. Yeah, and once again, it seems like we're missing that the 1Z and the 2Z, but you can see there's decent cape in the region, and we wanted it. This is a 3Z, so it kind of hurts it a little bit, but you can see the idea, right? 2,000 joules per kilogram in this little circle, 1,000 in this circle, but definitely plenty of it to go around. And you can see the cape. Again, warmer temperatures will bring stronger instability. You can see the cape did push its way north like so. Not super duper far, so we did get kind of that discrete mode because there wasn't super widespread cape. We have 3 cape and surface vorticity. That's something I like to talk about a lot in here too. It's kind of that bullseye, right? So this red area, that's our cape, and these little blue areas underlying them, that's our surface vorticity. You can kind of see here immediately, and I'll zoom in again. Right in this region, you can see that where surface low was about place was somewhere around here. Very big. Surface low was somewhere around here, and it would move its way like this. You can watch as we go along with this. There you go. You can see it, this huge swath of 3 cape that will go along with the system. All the way to 4Z as well, but at 1Z and 0Z here, you can see I have some surface vorticity in this little region here, which is about where we're seeing our storms. Kind of gives an assumption of what was going on. We got one discrete supercell, and that was what brought our tornado. But still for sure plenty of 3 cape here. That was the main reason why we saw our tornado was probably this huge swath of 3 cape. Again, after the fact, we're missing some data for the 1Z out or the 1Z products here, but you can kind of assume based on the 0Z what we're seeing strong 3 cape in the whole region, kind of fueling that supercell. However, you can also see again, it doesn't get very far north, and that means we got one dominant supercell out of really any convergence band pack, and that one was the one that was able to produce our Rolling Fork tornado. That's the majority of our things to go around with the meteorological outlook, just based on what we saw. Again, very well predicted. They knew they were going to see a tornado somewhere in here, maybe a few of them, and I believe we can see the storm reports as well. Here's our 20Z outlook. You can see though, mainly this one Rolling Fork was the main thing that came out of this event. We had a few other supercells. That color for that. We had a few other supercells. One right here. See kind of a line right here's one supercell that probably produced for a bit. Here's the Rolling Fork one that would cycle a little bit, and then eventually these would congeal into a line segment that do some wind damage up here. But mostly the tornadoes were from this Rolling Fork supercell, and that's what we're going to look at right now. So I also have the tornado archive data, very useful. You can see the same thing, right? The idea of one supercell that would cycle and another supercell stronger that would also cycle like that. That's all we really got at this event as well. I'm going to look at the radar imagery now as well. So here we are. This is from the Jackson radar. This is actually a little bit after the event, so I'm going to have to get a closer view of it. But if I look at the cities, Rolling Fork is situated basically right across the river. I seem to have lost it. Right across the river from, here it is. Rolling Fork is located right here. So you can see on both the maps here, Rolling Fork is right here. Zoom out again. Here's our Louisiana. Rolling Fork is basically right here. So we saw this supercell form really early and strengthen extremely quickly into the tornado it became. I'll get this out of the way. That's good enough. So we can start at 6 p.m. We had one ongoing supercell down here, actually kind of an impressive couplet and shape here. Close to the radar, not our main focus, but definitely impressive to see as well. So will it become our supercell's showery activity? You can kind of see the semblance of this convergence band I talked about. You see kind of a line of storms, kind of just a little showery activity. But if it's able to congeal enough, you can get one supercell that able to make its way through this sheared environment. Speaking of which, I will be looking at a sounding in a second from the SPC's pages. So apparently the National Weather Service does not have a archive day for this. So instead, I'm gonna take a little picture from Convective Chronicles video on this event as well. Also a very good video, I may add. So please check that out as well. You can see the sounding here, very strong curvature. This is an observed sounding as well, I believe. See up here, I believe this might be around Jackson. You can kind of see the wind environment, right? Uncapped, good cape values, not super duper strong, but plenty of cape in the entire. In that sense, lots of cape in the whole thing, very widespread. I believe as this event got closer, there's also stronger cape in the lower levels and stronger 3 cape associated with this as well. Again, very strong shear, and then precipitation would get sent out. However, it wasn't sent out very strongly, right? These storms were getting a lot of inflow. You can see right in this little region. That's I think it's about 40 knots of inflow right there, as well as not much outflow. Dropping this vector, that's about 20 knots. So these are high precipitation supercells. It's another part why this tornado was so dangerous, because you couldn't really see it coming. And many people, I believe, and a lot of storm chasers said this was like their most dangerous storm they ever chased, and a lot of people were in a lot of danger from it. So you couldn't see the tornado at all. Very dangerous in that sense. Really, just the entirety of this, just very dangerous as a whole. But the fact that there was this weaker outflow meant that was much higher precipitation, lots of rain falling, and this tornado was just very rain wrapped and hard to view. You can see the showery activity here, kind of messy, still very messy, but continuing to just ingest more and more showery activity as you go on. And basically, right as this gets towards the river, it begins to strengthen, right? Here's the Mississippi River in here, kind of bending around like so. That's our Mississippi River, and basically right as this passes, you can kind of see this little velocity couplet Rolling Fork is located right here. Continue 7:30, and right as this gets to the river, right here. These are inbound winds. Here's our outbound winds. You kind of see that semblance of rotation. Strengthen as it gets across the river. Again, stronger outbounds, stronger inbounds here. I could probably even take the about -40 here and +15. So it's about 55 miles per hour. I believe at this point the tornado or the system was tornado warned. And then right after you can see a significant strengthening. This may be a little bit of incorrect data right here with this blue. You can see it's very strong inbounds at this point. Say about -52. Outbounds around 40. So that's about 100 miles per hour couplet. So at this point, we have a very active, almost ongoing tornado here. And right as it gets towards Rolling Fork, this begins to strengthen even more. See how strong this couplet is. Might even be some folding in here as well. Very strong couplet here. Very powerful tornado in progress. And here you can see as it hits Rolling Fork, just you can even see a debris ball in there. But right here, there's a supercell, right? Here's the shape of it. A little mess, not exactly like that, but you get the point. You zoom in towards Rolling Fork as well. See this pink, which is very likely debris right in the center of that tornado. Very strong couplet, like extremely strong. These colors are negative 100 miles per hour on its own in this pixel, and then outbounds of 70 plus miles per hour. So extremely strong tornado in progress. It would strengthen right here for Rolling Fork, continue on its way, and I think it also hit Silver City. I remember that did some good damage here in Silver City as well. I believe EF4 as well. May have been EF3s, but either way, a very strong tornado hitting both of these cities. And basically afterwards, it would just move on. Still extremely strong and a long track, may I add. But you can see the idea of that supercell there. Very strong, and you can still see this couplet here. So yeah, here's our tornado. I believe. Might even be a secondary supercell. Okay, here it is. Behind it as well, there's another. I remember this day actually. There was this worry with this next couplet back here that Silver City was going to get hit twice. It might have even been hit twice, I believe, but the same area got under tornado warning twice in a row from two different storms within about an hour. So you can imagine how dangerous that was for a lot of us watching. I remember watching the Reed Timmer broadcast, basically all core kinds of broadcasts at the time. It was a year ago as well. So I remember watching a lot of these videos and live streams, just kind of understanding what was happening, and so many people were horrified. So you can see here, Silver City takes a direct hit from this tornado. See the couplet right over it, devastating the town at that point. And then that's at 8:37. Right here at 9 o'clock, 15 minutes later, another strong couplet, likely another tornado here as well, hitting Silver City. So we got very worried about that we would see strong damage, and then as people are trying to survive and get up and clean up that damage, they can't because there's another tornado ongoing right at the same time. Yeah, you can see our tornado here, still in progress, I believe, at this point. It goes into Winona. The tornado archive should still tell me about this. You can see it was a very long track. Hit Silver City. I believe, yeah, briefly lifted and then would hit Winona with EF3 intensity. We have data here as well. So this is the Rolling Fork damage reports. You can see a lot of EF2 widespread, EF1 widespread here. Then there just are little areas of EF4 intensity right in the center of this tornado. And then I believe Silver City is this. That's Winona up there. Silver City right here. Not as strong at that point, so luckily it did weaken. You can see the same thing with this one. EF2 intensity at Silver City, but still a very strong tornado nonetheless. EF2 is nothing to scoff at in any tornado at all. May I add. EF0 intensity is damage. That's a tornado hitting your house. So very dangerous for everyone involved. I believe it's also the EF3 intensity here near Window. Not sure here's Window. Yeah, so EF3 intensity kind of random spots with the structure that would hit. Luckily, it didn't hit a direct hit on Winona, but yeah, this supercell would go on to produce all this damage. But the main damage was definitely back here in Rolling Fork. All this EF4 damage. It's a huge wedge tornado, I believe, nearly a mile wide. I can also look at the correlation coefficient. So what correlation coefficient essentially tells us is what's in the atmosphere that is not meant to be in the atmosphere, right? So correlation coefficient, usually that's just like, oh, it's raining, or it looks at whatever's in the atmosphere and says, oh, is that rain? That seems about like rain. In our case, when we have our supercell going right towards Rolling Fork, see here, here's our in progress. Oops. Here's our in progress supercell just beginning. Remember, our velocity couplet was right starting in here. Crosses the river, right around near Rolling Fork, and you can see immediately just that's damage. Damage right there. That is debris in the atmosphere. You can see it even on the reflectivity over here as well. So here's our debris ball. I believe we can also get a size of this. See, the debris ball was like about a mile wide tornado hitting Rolling Fork. So impressive correlation coefficient. You can see the tornado also continues because of this debris ball continues. You can even see here the debris is being launched so far into the atmosphere. You have this huge swath of right here. All of this, that is debris being jetted off by the supercell. So if we have our couplet right about here, right, you can see on both sides. Our supercell is kind of shaped like this. Here's our tornado. Here's our couplet. There's our couplet, and that's all our debris above being just basically sent high up into the atmosphere. Again, it hits Silver City, and at this point, we assume that it dies out, or it lifts at this point. See, the correlation coefficient, the debris ball kind of disappears for a little before it retouches down somewhere outside of Winona here, right? That's how they knew that it lifted. The short period, a cycle here, right? And here's a debris ball. It'll move on this way, it'll kind of disappear. There it goes, it's gone. And then right outside Winona, touches down again. Yet another very strong tornado. Probably somewhere about another mile wide, maybe even bigger than that tornado on the ground there as well. And then it would hit Winona. Luckily, with less intensity, could have been very bad to see just a very strong tornado like that in both senses. Like even including EF4 intensity. EF2 is again still nothing. You can see radar footage here as well. Rays are hitting Rolling Fork, just that huge correlation coefficient right here. Much better data here as well. The data I have archived from the Jackson one doesn't really do this justice. You can see it's when it crosses the river and immediately just it's very strong over Rolling Fork. Unfortunately, I can't really pause this, but you can see here and over, just strong couplet. Go through one more time. Here's the Mississippi River right there, real quick. Franklin's really fast. Get that correlation coefficient ball right here. Debris ball. This is basically showing, I think, same thing. And that would weaken out once it lifts. So again, we can see right here, once it hits Rolling Fork, touches down right before it, huge debris ball right there. And then weakens out. Still hits Silver City though, another debris ball there as well. One other thing I found while looking at this data was the 7 a.m. surface observation. So you can see way back in here, surface flow kind of, it's way back in there, but you can kind of see a little better. The surface observations, right? This is 20 knots of flow wind barb, about 15 knots right there, 15 knots, 10 knots. You see plenty of strong moist convection. We kind of ignore this wind barb because of it was not 111 degrees that day. But you can see lots of strong southerly flow coming into the region, as well as good moisture in the morning hours. I believe there's also an outflow. You can see this outflow boundary that's shown by the surface observations here. But good moisture in this whole area, especially closer to the stronger forcing. 73 over 60, 63 or 68 even maybe. 74 over 70. Good moisture in this whole region. So the air that would rise would become very quickly moistened. And we see on the SQTs and stuff, kind of imagine this being our QT, right? So what we'll see is this temperature line somewhat like this, and then a moisture line. Kind of see a little bit of an inverted V, right? And if this temperature and dew points are very close, this air, you can imagine the air parcel being this black line here, this air becomes condensed very quickly, and that's how you get your stronger cape in the area. The closer dew point and temperature like this, these regions right here, 76 over 66, 77 over 64. That means that air parcels that rose very quickly become condensed into cloud cover, or in that sense, just they would fire, and that would be a good thing for this event. I also went back to show a little bit of the shower activity before. So you can see here our showers before this event, right? See a few little convergence bands as well as a stronger little thunderstorm area over here. This is at 4 o'clock, so about 3 hours, about for like 4 or 3 hours, 3 or 4 hours before the event would take place. See those semblance of those convergence bands, right? You can see a few little lines. Here's a line, kind of a line in this area, maybe bubbly cumulus, but kind of a few little lines of little showery activity. And as the time would go on, if these decide to converge a little bit or a little bit, you can see right here. Here's our first low convergence, right? The sort of showers are kind of pushing together, and these are going to kind of survive this shear. You saw that sounding I showed earlier. Strong enough shear can eventually, it can kind of rip these little showers apart. These won't form because they won't really be able to sustain themselves. When you have a bunch of them that stay together, like this bigger cell right here, this little congealment, they can kind of survive and eventually thrive. And I'm pretty sure it was one of these that would end up becoming our show. Unfortunately, this data is it's very good data, but it's very close together. I'll move an hour ahead as well, just to kind of see what's going on. Probably closer to our crossing of the river right up here. Yeah, as we get closer to the event as well, press play here to let it kind of play out. You can see this is at 5:30 and stuff. All these showers just keep moving north, and again, they're all congealed enough. Bad color. They're all congealed enough here. You can see they're staying together and they're kind of surviving this shear. So very interesting with that front. These would get closer to the river, and then eventually one of these would begin to fire, and that would take place to be our true show, and that real supercell right there as well. Get to the let me get forward in the data here. See right here, I believe even a little couplet begins. A little couplet begins to form at this point. Maybe it's very hard to see. But we use storm relative velocity sometimes. I don't know if this radar had it at the time, however. Okay, here's our velocity. I believe this is the storm relative velocity. Maybe a semblance, a little bit of couplet here forming as well. So I believe this right here was what would form our supercell after it crosses the river, and it would just strengthen immediately and annihilate Rolling Fork. Otherwise, there's not really much else for this event. Again, we had this the radar loop is always very interesting to look at. You can just see the damage, and then such a strong couplet as well. But this tornado was definitely a beast. Thankfully, though, it was very well forecasted, and we also know that the discrete nature of this event means that we didn't see multiple of these supercells really form. We only saw about two, maybe three up here. We had that one down here, the Rolling Fork one, then this other cell that would go in that region as well. But luckily, we didn't see a super duper strong event. We only saw those few tornadoes. But again, very well forecast event. SPC did a brilliant job at this. You know, and the storm reports are basically right on track with what we saw. Right. What we saw earlier was again not much strong hail was really forecasted. I think these are day 1 outlook, day 2 outlook. Sorry, but again, strong hail was not really in the forecast. Maybe some wind damage, mainly tornadoes. You can see that wind damage swath moved a little bit farther east as well. You can see that definitely stayed in store. SPC did a very good job forecasting this event. Definitely tragic all around. We saw a lot of damage here, and I believe the area of Mississippi where these tornadoes hit did get a state of emergency basically right after. So luckily they did get the relief they needed. And I definitely remember seeing a lot of people at the time, a lot of storm chasers were had these little fundraisers going out to help people. And definitely this is a huge reason why I want to do storm chasing and weather as a whole. It's all about helping people, and people definitely succeed in helping this day. Even just people that I would normally see just taking pictures of tornadoes, like even Reed Timmer, I saw him. You're like, wow, look at that huge tornado. That's always what you think of. You think of Reed Timmer, but he was driving someone to the hospital that day, and that's how I ended up seeing other people's forecast. Sorry, not forecasts, live streams when I was watching this event. So again, this event is very important to me. I got main reason why I'm interested in weather at this point in time. So huge important event for me, and I'm glad I've done a little case study on it. But with that, thank you for watching, and I will see you next time. And if you want any more case studies, please let me know. But that's the end of this video. Thank you for watching, and I'll see you next time.